welcome back, and in this video we're going to talk about an extremely important piece of information, which is reference angles. Okay, reference angles are extremely important to building what we call the unit circle. Okay, and there's some very special characteristics of reference angles. And you might be asking, what the heck is a reference angle? Well, I'll tell you. All right, now a reference angle. The reference angle is simply, reference angles are the angle formed between the terminal side of our angle, and I'm going to say theta, let's say our angle is theta. Reference angles are the angle formed between the terminal side of our angle theta and the x-axis. Okay, not the y-axis. I don't care about the y-axis. Okay, reference angles are the angle formed between the terminal side of our angle and the x-axis. Okay, so what that means is, let's say for example, we wanted to know what the reference angle of, let's say, 50 degrees is. Well, if I were to draw 50 degrees in standard position, it has to be in standard position. I would go up 50 degrees. All right. Now, the reference angle is an angle formed from the terminal side and the x-axis. And it's always, I should mention this, it's always an acute angle. Okay, so it's always going to be less than or equal to 90 degrees. I say equal to because, you know, we can have a reference angle of 90 degrees, of 0 degrees. We'll get to that in a little bit, okay? But it's always going to be some nice acute angle for the most part, okay? So what that means is, in this problem here, we want to figure out what this angle is formed from the terminal side and the x-axis. So what this angle is here, and in this problem, that angle is just 50 degrees. So the reference angle is 50 degrees, okay? So in quadrant 1, it's fairly straightforward. It's exactly how much you went, okay? Let's say we went to a different quadrant, though. Let's say I want to know the reference angle for 170 degrees. So if I were to draw this angle in standard position, 90 degrees, I'd have to go a little bit more. Remember, this is 180, so I'm not going all the way. So this whole angle here is 170 degrees. Now the reference angle is the angle formed with the terminal side and the x-axis. Well, the x-axis is right here, so what I want to know is, what is this little angle? Well, think about it. If this whole rotation is 180 degrees and I want 170, that means this little angle here is 10 degrees, which means the reference angle is 10 degrees. Okay, a reference angle can never be negative. I know I'm going back 10 degrees, I'm going back 50 degrees. That doesn't mean it's negative 10, negative 50, okay? It's always going to be a positive acute angle. So the reference angle of 170 degrees is 10 degrees, because I'd have to go 10 degrees further to go to the x-axis. Okay, we're always referring to the x-axis. Okay, let's take a look at just a couple more just to make sure we're on the same page. Let's say, I don't know, 240 degrees. Let's say 240 degrees. So 240 degrees is going to be in quadrant 3. So I'd go 90 degrees, 180 degrees. Remember, this whole rotation here would be 270. So I'm going to end somewhere like right around here. Okay? And the reference angle is the angle formed from this terminal side and the x-axis, which is right here. So I want to know what this angle here is. Well, think about it. I went 180 degrees, and then to go to 240, I had to go an extra 60 degrees. So the reference angle is 60 degrees. All right. Let's take a look at like maybe two more. Let's say, for example, we had something like, say, negative 200 degrees. Well, that shouldn't deter us at all. We know how to draw negative angles. We go clockwise. So I'd go negative 90, negative 180, and I got to go to negative 200, so I'd go another negative 20 degrees. So we'd be like right around here. And what I want to know, once again, is what is this angle formed here? That's what our reference angle is, okay? Well, think about it. I went negative 180, and then I had to go another negative 20 degrees. So this angle here is 20 degrees. I know our original angle is negative, but the reference angle is never negative. It would be a positive 20 degrees because the angle formed from this terminal side, if we think about it like as a triangle, the angle formed from this terminal side here and the x-axis would be 20 degrees. All right, let's take a look at just one more. Let's say maybe, I don't know, something bigger. 520 degrees, all right? Well, 520 degrees, that's going to be more than one rotation, but that's okay, okay? I would go 90, 180, 270, 360, 450, and now I got to go another 70, so I'm going to be like right around here. So that would be our rotation. And our reference angle would be the angle formed from the terminal side and the x-axis right here. Well, think about it. So I was here at 450. I had to go another 70, which means this little piece here is 20 degrees. So the reference angle is 20 degrees. And that's actually interesting. Take a look at these two problems. Notice two totally different angles, right? Two totally different angles. But they ended up in the same quadrant, and they have the same reference angle. Why is that? That's because these two are actually co-terminal angles. Okay, they actually have the exact same terminal side. They're in the same quadrant. They have the same terminal side, and because of that, they have the same reference angle. Okay, so that's actually another important piece of information. If two angles are coterminal, that means they're going to share not only a terminal side, but they're going to have the exact same reference angle. Okay, if you drew both of these in the same coordinate plane, it would end up on the exact same spot. And if you think about it, negative 200 degrees and 520 degrees are 720 degrees apart, which is two full rotations, 360 degrees. So they're coterminal, they share the same terminal side, and not only that, they share the same reference angle, okay? So that's reference angles. Definitely make sure you practice finding reference angles. They're very, very important pieces of information. We're going to be using them a ton this unit, all right? Until next time,